In scientific terms, a perfect vacuum is a theoretical concept that refers to a space that contains no particle regardless of the pressure unit that being used. This concept is based on the definitions of vacuum as a volume that contains little or no matter. When molecules or gases are initially present in a sealed container, they exert force upon colliding with each other and to the container's wall. This collision to the container will result in pressure. By connecting a vacuum pump to the container, it is possible to remove almost all gas molecules, which subsequently will reduce the pressure inside the container to nearly zero. This pressure is known as absolute zero pressure or absolute vacuum. However, it is important to note that achieving a perfect vacuum in the real world is nearly impossible due to several reasons. Basically, there are no device that can remove every single atom or molecule from a sealed container. Earth is surrounded by a layer of air called the atmosphere. The atmosphere is composed of different types of gases like nitrogen, oxygen, and traces of amount of other gases like argon and carbon dioxide. The weight of these gases exerting force on the Earth's surface and everything on it. These forces create what is known as atmospheric pressure. Pressure is the result of the mass of air molecule being pulled toward the Earth by gravity. It is important to note that this pressure is exerted in all directions and not just downward direction. One way to measure atmospheric pressure is to fill a test tube with mercury, then invert it into a ball of mercury. Usually, pressure is measured using two types of reference. The first reference is known as the atmospheric pressure. In this approach, we are calculating the pressure relative to the ambient atmospheric pressure. The second approach is known as the absolute zero pressure or absolute vacuum. Absolute pressure is the pressure measurements relative to a complete vacuum. This type of reference considers the actual pressure exerted by a fluid or gas and is irrespective of the surrounding atmospheric pressure. So, what is the key difference between these two references? As the name implies, atmospheric pressure is the pressure measurements that is relative to the atmospheric pressure, while absolute pressure is an absolute measurement where the pressure measure is relative to a vacuum. Imagine we have a deflated tire and we are using an absolute pressure gauge. As I mentioned previously, this type of gauge measure pressure relative to a complete vacuum. Therefore, when we use an absolute pressure gauge on the deflated tire, the reading should be equal to the current atmospheric pressure. This is because the force is actually the force that is exerted by the surrounding air molecule pressing on the outside of the tire. This force is as depicted by the red arrow here. However, if we use the same absolute pressure gauge to measure an inflated tire, the reading will be equal to the sum of the current atmospheric pressure and the gauge pressure. Gauge pressure is the pressure exerted by the gas molecule that is colliding with the inside of the tire. Therefore, absolute pressure is equal to gauge pressure plus atmospheric pressure.